The previous videos, we have discussed about the differentiations of the common functions. We can use the equations to help us to do the differentiations of the functions, provided that the functions constitute of common functions in a single term, which is relatively easy. However, if we encounter the functions which constitute of multiplications of two functions, which is u and v, the solutions will become slightly more complex. This can be solved by using these equations. The u here represent the first functions and the v here represent the second function. After differentiations, you will obtain u dv dx plus v du dx. Without further ado, let us try the examples for the product rules. The equations given is y 3x power 2 sine 2x. It constitutes two common functions here. You may separate them into u and v. Let's say we set u equals to 3x power of 2 and v equals to sine 2x. Differentiate the u functions. This gives you 6x. And differentiate the v functions. You will get 2 cos 2x. Adopt the equations for the product rules. Substitute u dv dx v du dx into the equation. Reorganize the equations, give you this. Simplify it by taking the common function out of the bracket. You will get the final answer. Let us try another examples for the product rule. The y equals to 3 square root of x ln 2x. This constitutes of two common functions. Let u equals to x power 1 per 2 and v equals to ln 2x. Differentiate each of them. You get the functions here. Adopt the product rule. U dv dx plus v du dx. Reorganize the equations and simplify the equation. You get the answer. This is another example of product rules. What you see here is constituted of three functions. However, the product rules is only applicable for two common functions. With that, you need to do the product rules for two levels. Let us resolve the first two common functions. Let u equals to x power 3. v equals to cos 3x. Differentiate both u and v in terms of dx. You will get these two terms. Use the product rule. U dv dx plus v du dx. Reorganize the equations, you get this. That means, if you differentiate the two terms here, you will get this. Now you need to do the product rule for the second level. Since we already have the differentiations for the first two terms, you may set your u equals to the first two terms, while the v equals to the third term. Differentiations of this u will give you this, which is the one that you have generated just now. and differentiate log x, it will give you 1 per x. Use the product rule. U dv dx plus v du dx. Reorganize the equations, you will get this. Let us try one more question. It is given that v equals to phi t sine 2t. The question asks us to determine the rate of change of voltage when t equals to 0.2 seconds. First, you need to know what is the rate of change of voltage. When you are talking about the rate, that means you deal with the dt. Differentiate this dv to dt. It represents the change of voltage by the rate of time, dv per dt. And the equations for the v here constitute two common functions. Let u equals to phi t, while v equals to sine 2t. Differentiate both u and v to the dt, and you obtain these two. Use the product rule. U dv dt plus v du dt. Reorganize the equations, you get this. The questions ask you to determine dv dt when t equals to 0.2 seconds. You will need to substitute 0.2 into the equation here. And you will obtain this. The 0.4 here are in the form of radian. Solve this, you get dv dt equals to 3.79 in the form of 3 significant figures. For most of the mathematical questions, unless it is specified with the numbers of significant figures or the numbers of decimal places, you may always use 3 significant figures.